So next is incidence matrix, or otherwise called as vertex matrix, which is denoted with matrix AI. So here we can realize this topic, that is incidence matrix or vertex matrix of a network topology or graph theory, by taking an example. So here I am taking this example to realize this incidence matrix. So here this is one oriented graph. So directed graph. So here how many nodes are there? 4 nodes are there. A 1, 2, 3, 4. And 6 branches are there, and the directions are given to that branches. Now we have to get incidence matrix AI. So here in incidence matrix, number of rows is number of nodes, and the number of columns is a number of branches. So here there are 4 nodes in this oriented graph, directed graph. So that's why we get 4 rows in this matrix, incidence matrix, and number of columns are number of branches. So here it is 6. So for this example we get 4 by 6 matrix. Now we have to fill this matrix by column wise. So first branch, take first branch. It is connected between 1 and 2. So that's why you take 1 as +1 and 2 as -1. So it is in between. So 1 and 2 becomes the non-zero elements. And 3 and 4. So the first branch is not at all related to third branch and fourth branch. So that's why this becomes 0. So again in these non-zero elements, as one is leaving node 1 and coming to node 2, so leaving node, it is leaving at node 1, that's why +1, it is coming to node 2, that's why it is -1. So similarly, to fill second column, so that is the second branch is connected between second node and third node. So that's why second one and third one are non-zero elements, and it is not at all connected to first node and fourth node. So that's why it is 0 and it is 0. So it is leaving at second node and coming to third node. So that's why for second node +1, for third node -1. So similarly, to fill third column, so third branch is connected between 3 and 4. So that's why 3 and 4 are non-zero elements, and remaining 1 and 2. So this is not at all connected to first node and second node. So they becomes 0. And again in this, it is leaving third node, it is coming to fourth node. So that's why third node is +1 and fourth node is -1. So again to fill fourth branch, so there is fourth column. So fourth branch is connected between second node and fourth node. So 2 and 4 are non-zero elements, and 1 and 3 are 0 elements. So again it is leaving at second node, coming to fourth node. So leaving at second node +1, coming to fourth node -1. So fifth branch. So fifth branch is connected between first node and fourth node, fourth node. So they becomes a non-zero elements. And second one and third one are 0 elements. Elements value is 0. So it is leaving at fourth node and coming to first node. So leaving at fourth node +1, coming to first node -1. So last branch, sixth branch. So sixth branch is connected between first node and third node. That's why they are non-zero elements. And second node and fourth node are zeros. So again in this, leaving at first node and coming to third node. So third node is -1. So in that way, we can get the incidence matrix or vertex matrix. So incidence matrix or vertex matrix defines about the oriented graph. Just simply, it defines the oriented graph in the form of a matrix. So here each column, if you add the column elements in the column wise, it becomes 0, +1, -1, 0, 0. 0 +1 -1 0 is 0. So if you add all the elements of a column, we get a 0. So after removing, if you remove any one row of this incidence matrix, it becomes a reduced incidence matrix. So when a row is eliminated from a complete augmented incidence matrix, the remaining matrix is called reduced incidence matrix. So if you remove any one row of the augmented incidence matrix, then whatever the matrix we got is a reduced incidence matrix. So if augmented incidence matrix or incidence matrix is 4 by 6, order of the matrix is 4 by 6. So reduced incidence matrix order is 3 by 6 matrix. And similar manner we can plot the graph using incidence matrix, because incidence matrix defines about only the oriented graph. So here in this example, incidence matrix has been given. Now we are asked to find oriented graph. So here number of rows is 3, number of columns is 4. Means in oriented graph there are 3 nodes and 4 branches. So locate that nodes as 1, 2, 3 like that. So here if you see first branch is connected between 1 and 2. First branch is connected between 1 and 2, and current is leaving at first branch and coming to second node. Current is leaving at first node and current is coming to second node. So similarly second branch is connected between second node and third node. So second branch is connected between second node and third node. So it is leaving at second node and coming to third node, leaving at second node, coming to third node. So similarly third branch is connected between first node and third node. So first node and third node. And it is leaving at third node, coming to first node, leaving at third node and coming to first node. So similarly fourth branch is connected between second node and third node, and leaving at the second node, coming to fourth node. So if oriented incidence matrix is given, we can get the oriented graph, because incidence matrix defines about the oriented graph. Incidence matrix explains about the oriented graph. So similarly if incidence matrix is given, we can get the oriented graph.